All right, this is quiz 3, pre-algebra. Questions 1 through 3 is determining if something is a function. Now, a function, for every input, there's exactly one output. Explaining that meaning, if x repeats, then the y has to repeat underneath it. But if x repeats and the y underneath is different, then that's not allowed. You're not allowed to have two different y's for the same x. For an example, let's say you have a chart. Okay? I'm going to do one that works and then do one that doesn't work. So these are x and these are y. Okay? And this is a function. So 3, 4, 5, and this is 2, 7, 2. Now, y is allowed to repeat, but x is not allowed to. Okay? So let's say I change this 4 into a 3. This is not allowed. This is not allowed. You're not allowed to have 2 3s. Not when you use 3 in the function, you get 2, and when you use 3 in the function again, you get 7. That makes no sense. Okay? That's not allowed. For every one input, there has to be one output. Okay? So this cannot be that. So this can be 6 and 7. That's totally allowed. Okay, now yes, the y can repeat. This is still a function. So that's allowable. On a graph, okay, on a graph, to make sure that this is a function, you have to just do the vertical line test. Okay? So if this is a straight line, then yes, that is a function. Okay, that's a linear function, but it's a function for sure. Okay? If it's graphed and it looks like something like this, that's still a function. Now, if it comes back, that's not a function. Now, why? Because it's not passing something called the vertical line test. Meaning, if you cross a line like this, okay, if it intersects at some point, boom, with the line in two different spots, then it's not a function. Why? Because this one x has two different answers, which we just said is not allowed. Okay? So if you see something like y equals 3x, okay, this is not gonna, I'm not gonna put a 3 into this equation, okay, and then put a 3 again in the equation and get a different answer. Every time I put 3 in that equation, I'm gonna get the number 9 as the answer. Okay? So, seeing as though this is a function, this is a function that's acceptable because this will create, okay, a linear function actually, so you know it's a function. This one here is a function, and this one here is not a function. Okay, so what you're doing in question 1, 2, 3, I'm showing you something like this, I'm showing you something like this, or I'm showing you something like this, and you're telling me, is it a function or not? Okay, if it's a linear function, you know it's a function. Okay, if it's not, you still know it's a function. Okay, these are pretty difficult to make not into a function. Okay, here we go. So, for question 4, you're going to get something like this that says, remove the dot to make it a function. Because right now, this is not a function. Why? Because there's 2 dots for this one x. Okay, so if I erase this, now it's a function. Okay, so you need to know which dot you have to remove. What was the name of that dot? That dot is called 1, 1. So what's the dot you have to remove? 1, 1. All right, question 5 through 8 is the initial value or the rate. Okay, I'm going to show you the 3 different ways that you can do this. Now, for the graph, okay, for the graph, where it is at 0 is its initial value. So if it starts right here and you check and here it says 7, the initial value is 7. Okay? For the rate, you're looking for somewhere that it crosses exactly at an intersection. Okay? So let's say this is 8 now and this is 2. All right? So how much did it have to go up to fall into this perfect spot? It only had to go up 1. So you do y first. So y goes on the top and x goes on the bottom. So here it's 1. And what about the bottom? How much did it have to move to the right? It had to move 2. So this is 2. So the rate for this one is 1/2. So the rate is how fast it's increasing. So this is going to be continuous because this is a linear function. So it's going to be there, and then it's going to happen again, it's going to happen again, and so on and so forth. So the rate is the rate in which the line increases, okay, which I just showed you. You find one dot, you find two dots that are on exact intersection. The initial point is a good start, and then the next one's a good start as well. And then you look at the bottom. X is going to be on the bottom, and the Y is going to be on the top. Okay, and that'll be it. That's the rate. The initial value is where it starts. Okay, let me clear this. Okay, so let's do a chart. So these are all functions. So you're just telling me what the rate is. So let's say it's 3, 5, 7, and this is 8, 16, 24. So how is 3 turning into 5? How is 5 turning into 7? So this is going up by 2's. Okay? And this here, this is going up by 8's. This is going up by 8's. Okay? So Y is on the top. So this rate is 8 over 2, which really equals 4. So the rate for this is 4. Okay? Now usually in these things they'll give us, if you want to find the initial value, that means they're going to have to give you what X is. Okay? For 0, this will be negative, so that'll be 0, negative, so negative 16. So negative 16 for this one. So this is X and this is Y. So what's the initial value? What's the answer when X is 0? The answer is negative 16. So this is the rate, and the initial value is negative 16. All right, and now I'm going to show you what it looks like in an equation. What it looks like in an equation. All right, so this is going to be, let's say I tell you this, y equals 3x plus 7. Okay, this is the initial value, so initial value and this is its rate. Okay? So what's the initial value? 7. What's the rate? 3. Now what if you get something like this, Mr. Castris? Boom. What's its initial rate now? It's 0. There's nothing there. 0. Okay? And what's my rate? 2. Okay? What if you get something like this? Okay? The initial value is 9. Or if I erase all this and I put a minus here, it would be minus 9. Okay? And what's the rate? Mr. Castris, it's 0. No, there's an imaginary number here. You should know that there is a 1 in front of this x. There's one x right there. Okay? So the rate for this one is 1. There can also be fractions here. What's the rate of this one? 2 over 3. What's the rate of this one? Okay, the rate of this one is 1/5, and what's the initial value? 9. Alright, so that's what these are about. 9 through 12 is it a linear function or not? Okay, a linear function is constantly increasing at the exact same rate. Okay, like I showed you, a linear function is a straight line. So if I show you a graph and say, hey, is this linear? You'd say, yes. But if I said, hey, is this linear? You'd say, no, because it's not a straight line. Okay, so a graph is simple. The other ones are simple as well for when you're looking at a chart. Okay, X, Y, 1, 2, 3. This will be 4, 5, 6. So this is going up by 1, this is going up by 1, this is going up by 1, and this is going up by 1. So this is, the left is consistent and the right is consistent. So this is going to be yes to a linear function. So you're meaning all of them are the same? No, this can go 2, this can go 4, 6, 8, and now they're going up. This is consistently 1, and this is consistently going up by 2. This is still a linear function. Now, how does it look like when it's not linear? Okay, this would be not linear because it's going up by 1 and then it's going up by 2. It's not following a pattern. So this is a no for linear function. Now, for linear functions, when you're looking at them here, okay, it has to follow the pattern of y equals mx plus b. Okay, you're allowed to add to the x. You're also allowed to subtract with the x. You're also allowed to multiply with the x. You're also allowed to divide the x by a number. What you're not allowed to do, okay, so these are all linear functions. This is linear functions. So this is a linear function. This is a linear function. This is a linear function. Okay, these are not linear functions. This is not a linear function because it has an exponent. Neither does this one. This is also not a linear function. This is also not a linear function because the x is in the bottom of the fraction. Okay, these are not linear functions. Linear functions, you're allowed to add, subtract, multiply, divide to the x. What you're not allowed to do is have the x in the bottom, have it be a square root, or have any kind of exponent at all. Okay, so that's what's going on in the last 4. You're telling me, is it linear or is it not linear? And that's it.